Hello everyone, welcome back to What's What. In this episode, we are going to talk about connections, how important connections are in society. I'm busy. We're connected in one way or another via the internet, everyday life or the universe. But what if electricity was the same? Imagine an electricity grid that connects the entire planet via power cables. Will it ever be possible? And what are the economic and technical challenges to such a goal? That's what we are about to discuss. But before we get started, do not forget to like and subscribe below. We've discussed in previous episodes how interconnections between countries help to prevent blackouts. We've seen flagships like the Aurora vessel and how it lays cables across seas to interconnect countries. We've seen the power of submarine cables. And we've seen the power of power grids. But where do we go from here? Longer transmission lines and the increase of interconnections between countries benefit users in different ways. With mutual assistance between operators, connectivity allows us to help our neighbors with power supply, with off-sharing and demands where needed. Thus, we have a greater balance due to the size of the infrastructure between generation and consumption. But this larger connectivity is only made possible by more cost-effective technologies, including AC-DC conversion at a large scale. And with new technologies, we are able to import renewable energy from where it's captured and stored to anywhere in the grid, like, for example, with offshore wind farms. Just a few decades ago, submarine cable systems were only used to connect island to mainland operators, and these connections were typically a few kilometers long. The development of renewable energy, especially regarding large-scale offshore wind farms, have contributed to the rise of powerful and vast submarine cable linkage. Where before we transferred already stored energy, now we are transporting energy from its source. In modern times, it is common that the supply of electricity is carried over several hundred kilometers from offshore to control station, then dispatched throughout the grid. That's called making connections, people. Of course, this connectivity comes with investments, research, developments, and operation feedback. Not easy, no, just more advanced. To put things into perspective, let's take a look at this interactive map of Northern Europe. It displays the current spread of offshore wind energy. This map consists of operating lines and lines under construction, as we can see here. And if we consider links between offshore farms, we can start looking to the future of connections. Power hubs are like artificial islands. They take the energy from offshore wind farms, transform it, and send it where it needs to go. Power hubs can come in the shape of platforms, caisson islands, and sand islands. Some examples of power hubs include Princess Elizabeth Island, Dogger Bank, and two others in the North and Baltic Seas. TenneT, the Dutch TSO, has also published an impressive target grid displaying where countries are to be interconnected by these hubs. Looks like it's all coming together, and it's all about electricity. Interconnections already play a huge role in how our grids operate. More than 400 interconnections are operating here in Europe as we speak and provide electricity to 600 million citizens across countries. So here comes the real question. Can we increase power cable distance and interconnect continents? Our oceans are already covered in data cables, those information highways that carry around 99% of the world's communication, the essential tool to operate the internet. But data cables are smaller than power cables and easier to install, as mentioned in a previous episode. Still, What the two have in common is that they are assembled with a similar steel armor. So what we did with data cables for communication, can we do with power cables for electricity? With submarine cables, more factors come into play in regards to interconnectivity. First, every time you go 10 meters underwater, pressure increases by the measurement of 1 bar. 1,000 meters deep, that means 100 bars of pressure. That's no joke, but companies are designing cable-laying vessels that can withstand such force as we speak. And the final product may be here before we'll know it. Cable systems and their joints must be able to withstand extreme pressures and remain operational for several decades, because repairs at such depth can be difficult and very costly. In essence, we can't just make connections, we have to maintain them. Let's take a daring project that illustrates this context and stakes. Investors in the electrical industry have planned installation of a subsea interconnector between England and Morocco. At first glance, it may seem odd that the most direct route is not taken to connect the two countries, but the shortest alternative path would cross the Biscay abyssal plain that is 4,000 meters deep and has over 400 bars of water pressure. Another example, the Biscay interconnector between France and Spain, which does not cross the Gouffre de Cap-Breton. Not familiar with the Gouffre de Cap-Breton? Well, it is similar to the Grand Canyon, just underwater. Hard to make a connection there. So what engineers did with the Biscay interconnector was made a short incursion on shore, then reconnect the power cables underwater after a critical crossing point. That's not all. There are other similar projects like the IceLink, which would connect UK and Iceland, and the AA Power Link, which would piece together grids of Australia and Singapore. But these projects are still in their development stages. We'll have to stay tuned to get more details and see how the connection continues. How about a quick recap to sum things up? Interconnecting grids already exist and are very common between countries. Interconnecting continents with deep-sea power cables is a viable reality in electricity transmission. The development of such grand-scale projects increased with utilization of offshore wind farms. Various proposals are already underway, including the AA Powerlink and IceLink. What do you think? One grid to connect us all? When will it be made possible and how? Is mutual connection and sharing the way of the future? Feel free to leave us a comment below. Until next time, this is Frédéric from What's What Studios.